Okay, change the stream information. So, and of course, it's unstable. That's unfortunate. Let me try closing some stuff to make sure that it looks a little better. Okay, so I'm probably just gonna have a bad frame rate. I can't really do anything about that. I'm sorry. Um, but if you have been on my channel before, you'll know I've been making, or either Twitch or YouTube, you'll know I've been making a lot of Stardew and game-related applications, and I still want to work on those. However, I've been realizing that I'm not really good at prioritization, not just in uh, programming or software engineering in general, but also with my life. And so I've been using Todoist, which, if you're not familiar with, is just a application habits and just to-do lists in general. I like it a lot, but there are some features locked behind paywalls, and I don't want to pay for them. It probably would be probably a lot less work to pay for them. Um, but I feel like there are some features limited behind the paywall, or even with the paywall, without the paywall, that I just want to make my own app. I've been wanting to do this for years, actually. I think at least 2 to 3 years now, but I just never got around to it because I always felt like, okay, well, I don't really have it fully planned out. So once I get it fully planned out, I'll uh do it, but never got around to it. And I'm like, okay, well, my life is falling apart in the sense of just like I feel like I can be more productive, and I'm not just not happy with how things are currently. So let me just do it. Um, and just get started. So I am working on a roadmap. I will say that I am using ChatGPT in the sense of just like helping me with documentation, as I'm not really familiar with it. I'm not gonna fully rely on it, but I am going to use it more of just like a stepping stone. But I am going to be doing most of the work in both documentation and implementation. So if you have any problems with that, I'm just letting you know right now. I don't really want to have a debate about it. I'm just using it as a tool. So this is what I have so far. It's just a roadmap. So I gave it some features I wanted to do. And I want this at least a workable product by the end of December. So, or technically by the end of October, but we'll get to that in a second. So I'm going to be on vacation for starting the week of the 2nd, so I don't really feel like planning anything for this week. So I am not really saying I'm going to start working on this project until the 15th. And then I'm going to use the following 2 weeks after the last 2 weeks of July to plan out my MVPs, or how I want the application to work, and what's the word? Just flesh out the plan and what features I want and what I'm going to be working on for the next upcoming months. So this is a general roadmap. So first thing we need to do is figure out what kind of programs are we going to use. Are we going to use the front end and back end? What kind of language? Is it going to be React? Is it going to be front end? Um, I'm decided to just, for front end, just start with the CLI, just so it's not as much work and I don't have to worry about the details, or at least the visualizations just yet. But then I'm going to have to set up the repo. And if you guys saw any of me working on my Stardew bot on Discord, I feel like that was the most structured I ever had a project. And I think it helped with development, although it definitely had some things that could be improved on. But generally, I think it was pretty good. So I'm going to keep 3 branches: main or master, whatever it prefers to. I don't really care. That's going to be the release or production. Development is where all PRs are going to go to. So they're going to be branched off of main into development. And so if anyone, including me, wants to add a new feature, it first needs to go into development, or the PR needs to target development. And then once the development branch is, once that feature is like tested somewhat, it's going to go into staging. And staging is pretty much the last part, QA testing, before stages go into main. So the order is development, staging, main, and then back to development. So although I don't really plan having this project be worked on with anyone besides me, but I do think it's good practice, so I'm just going to keep that. And then I'm going to have a few files. I'm going to have a README, which is mostly just going to be for either people who want to work on the project as additional developers and customers. So people are going to who are going to be using the application. Again, at the moment, only I fit both of those roles, so it's not really necessary. But I going to assume there's going to be at least one point in this project's lifetime in which I forget something that I originally planned, and I would rather have that written down for me to remember later than just forget it forever. Again, this project is supposed to be more for documentation and just like bettering my life, so I feel like it's better to get everything done early or get everything set up as early as I can so I don't have a very bad time in development later. All right, roadmap, that's what this document is. Again, it's just a general idea of how I want things to be planned out. You can see I have it based on the month and the general tasks that are going to be done in the month, and then those specific tasks being broken up within each following week. Project plan. Project plan is going to be similar to the roadmap, in which it will say generally what each feature I want, but it's going to be more detailed, and it's not really going to have a roadmap, or at least rather a timeline like this. It's mostly just going to be the epics and acceptance criteria and user stories written out in detail. So this is just going to be more detailed, and this is going to be for more for me or whoever the developers are. I can give you an example actually of how. Let me give you guys an example of what I mean by these documents, so I'm just not talking to air. Also, please let me know if the volume is too loud, either my voice or the music, or too quiet. All right, so for my Stardew bot, I have made a README. So this README is just mainly for people who want to use the bot in any way. So it has a description or overview about what the bot is for, along with a link to my server if you want to check that out. My Stardew server, rather. And the purpose of this bot is to automate streams notifications. So if I'm ever live on Twitch, which it should give me, if you are in that server, you should get a notification in about 27 minutes. But it also shows when I'm uploaded something on YouTube, whenever beta builds or mods releases are uploaded. So that's the general reason of it. There's going to be more things that go along with this, but this is a general purpose. But as you can see here, you have the tech stack. So this is all in Discord.js, so it uses JavaScript. And then you have the branch structure, which I already talked about, but here's it better laid out here. And then you have requirements. So since this uses Node, there's a lot of packages you need to use. So here's those respective ones along with the version that the project is using. Setup instructions, so how to clone it, get all the repos, get all the packages, getting the environment variable set up, and then how to run it on your local server. And then we have how to make a PR, or rather a general template. I'm going to probably change this to be an actual template because I did not know GitHub had that feature, but now I do. So I'm probably just going to, in both this project and in the task tracker, make those templates and just link to them from the README. But yeah, general idea is to have a description, and then if it's a bug fix, say explicit steps to reproduce the bug, say the expected behavior, what's supposed to happen, and then describe what actually happens and how your bug fixes it. For new features, similar to bug fixes, you say step-by-step instructions in order to test a feature, and then adding any media or notes would help as well. And then I have the MIT license. So that's what the general README is going to do. The project plan, I also have somewhere in here, right here. Come on, thank you. So project plan, similar to the README, it has a general project overview / introduction, which tells the purpose of the project, the objectives that the project should achieve, along with functional and non-functional requirements, and then very similar things, technology stacks. But as you can see here, this is where the project plan gets a little bit more detailed than the roadmaps and the README, where we have epics. So this is like the main topic of the feature, if you will. And then user stories you can think of as specific features. And then, so you have the name of the feature, the description about what it's supposed to do or what it's generally going to achieve, and then a user story, for which people who aren't as into software engineering, user stories are where every feature should have a purpose, and it shouldn't just be there to be there. Therefore, someone must be affected, or someone must be affected by the feature being implemented, either in a good way or a bad way. Most of the time, in a good way. So in this context, you try to say who the role is, and so in this case, it's a Discord user. So as a Discord user, with the notification stream notification rule, I want to be notified in this channel when Hawker goes live on Twitch about a stream late to Stardew, so I can join the stream live. So we have the role as a Discord user. What do you want to do? So in this case, I want to be notified in the channel when Hawker goes live. Why? So I can join the stream live. It should say as soon as it starts, but or general time when it starts, but the general thing makes sense. So, and then pretty much the same thing for the other Twitch stream. So for each epic, or excuse me, for each user story, we have acceptance criteria, which is exactly the exact details, things that need to be done in order for this user story to be complete. And it's very good to do this because it helps you check for edge cases before you start implementing, and so you don't have to blindly or just like run around and probably rewrite a bunch of code. So I want to do this for every single epic. When I first made this project plan, I think I only did it up to epic 5. And then when I added more features, or once I finished these features, I was thinking about tasks I should add, and so I kept them in a backlog section. And then once I was done with these epics, I was able to basically start another version of the plan and then add more epics. That needs to be deleted. Well, very small. Oh, excuse me. So after I finished epics 1 through 5, I went to my backlog section and I was like, okay, I want this, this, and this, and so let me try to document those and then create additional epics. So now I guess you can think I'm in version 2 or milestone 2 of this project. I haven't really been keeping up with milestones. I've been more keeping up with versions and change logs, but they're generally the same. So after you do all the epics, I then have a backlog feature header, which, like I said before, is just general ideas that I have thought of, but I have not fully thought through of if I should even implement them, and if I did want to, how would I do so? I think it's better to just keep them over here and just keep within your scope and then expand once you have something concrete. So that's the project plan. And speaking of versions, you have my releases here. And just has general idea or general things, features, bug fixes, things added to the repository. Um, but I got this mostly from my changelog, which I am planning on using a lot more in my future projects. So a changelog I got from this website, which is pretty much just a file that keeps track of what was changed, what was added, what was removed in each version of the application or the project. And it's very useful. So you can one keep consist or rather keep version control and see what was added without going through the commit history or PR history. And actually allows you to really write releases, these notes releases, because you can just copy and paste whatever you have from there from the changelog into the release notes. So it's very helpful. But general thing is you have a changelog. I just kept these things here for me to remember how I'm doing semantic versioning, which pretty much just means how these numbers are done. So this is basically main, very big project update, minor update, and then these are tweaks slash bug fixes. Plus the last one is tweaks slash bug fixes. Okay. So as long as you usually just keep this updated after you like merge a PR, then this should be fine. And it helps with planning as well to see where I am. So those are all, or most of the files rather, that I want. Did I miss any? No? Okay. All right. Last one is a dev diary, and this one I'm not very confident on, which is why I have it under um, the wiki as opposed to as a file. I'm probably going to keep this. I'm going to keep this in a Google Doc. So a dev diary is pretty much, as the name implies, a document in which developers write their thoughts about a project. Sometimes it's written as just a retrospective. Sometimes it's there for people, kind of like a rubber duck, to just talk things out, whether you miss an edge case and you just need to think about how you're going to fix it. Writing it out or talking it out can be useful, and it could be useful for your future self. If you forget why you implemented something like this, then you can just look back in the past notes. Now, I have done documentations in which I critique my peers and myself in retrospectives, but I never really have done anything like a dev diary in a sense of me documenting my process, because it's kind of feels a little redundant if I have the project planned and the change log. However, I do think dev diary will be a good case in which if I ever need to um, think about something, it's like, okay, what happens if this happens? And I don't want to just forget about it. That may be the best place to put it. I'm not really sure of a structure for one of those. So that's what I'm a little concerned about. But I'm not going to worry about that right now. I'm probably just going to keep this as Google Docs and just write anything that I have that just pops up to my mind, and then I'll write it there, and then I'll look back a bit at probably at the end of the week and just change from there. All right. Next thing I need to do is GitHub Actions, which I want to have unit testing. I want just to have 100% unit test coverage, just so I know everything works as intended and I don't have to deal with anything. So having that set up here will be very great. Similar to making sure everything is just clean, I want to have linting rules. Again, I need to figure out what application or which language I'm going to be using in order to figure out which specific, how, or at least how I'm going to lint things. But that's just to make sure the code is consistent and I don't have to automate it myself, and I don't have to like manually do it myself. And if other people go on the project, work on the project, and they have different coding styles than me, then at least the program can equivalent it in. I won't. It'll make sure I don't have like bloated, sorry, bloated, or unused like app files. Like let's say there's a function that's declared but never used. I can just delete that, or the linter can say, hey, either delete this or do something with it, but it can't be in here. I'm like, cool, I just delete it. I already talked about PR templates already, so let's skip that. GitHub project. So currently, what happened to my music? Okay, so playing. All right, so currently in my Stardew bot repository, I do have a project. It's more of a Kanban file, or excuse me, structure, where, come on, I have things in different boards. So it starts off as no status. So these are all PRs that either I know I have only made them, but these will be where someone else has like put them in. But they should, once a PR is made, or excuse me, not a PR, an issue. Once an issue is made, it should go into ideas. This is kind of like the backlog section, but not really, because we don't know if it's really going to be backlogged or not. But you can kind of think of it as a backlog, more than just like ideas to like think about and consider. To dos are things to do. Since this is more of a Kanban project, and I just put everything in it at once, these are all every single epic that I already made is in here, along with their respective acceptance criterias, which I have made as subtasks or sub issues. And you can see the user story, exact same user story, exact same description, and the respective acceptance criterias. Then I have labels, and then if I were going to have someone else work on this project, either that person or me would assign myself to it to verify no one else is working, to verify no one is overlapping on work. And then if something is currently in development, then you put it in progress. Yeah, nothing really else to say there. If it's needs to be in review or is ready to review, then you put it in review. This is when the PR should be up. Although these are all related, so although these are technically done, this needs to be done before it's fully in review. And then you have done. Done is pretty much if the PR/issue is completely finished. At this point, it would probably be in, not probably, it will be in staging, in which various or just tests will be made to verify, and then depending on how many features are in that or in that staging PR, or yeah, staging branch, we'll probably either wait for more features to be added just to make the latest build not as update so frequently, or we'll just push it to the latest build. And that's where this is. So everything in here is in the latest build. I think I'm going to keep this project, or at least this view, because it's very helpful. Though, given my roadmap, I'm most likely going to also add sprints. So week 1 would be, well, technically yes, sprint. This would be sprint 1, sprint 2, 3, 4, etc., etc. And that will help me with just figuring out retrospective and just whatnot. Now, I that's pretty much it for the GitHub repo. I know I went through a lot. I'm mostly doing it for my sake, but also explaining it to people who aren't as aware or not as experienced in software engineering, because I want this to be a learning experience for myself and others. So that's it on the repo, and then I have create initial roadmaps. Um, this is pretty much just like a updated version of the current roadmap, because while I do have them listed out, it's kind of vague in general areas, and I don't want to do that. So, right. Excuse me. All right. So, like I said, today is the 6th, and while I am not forcing myself to do work, I do want to get started just in case I have any plans to change something in the future, and just to give myself more time to work things out. As I know this is not gonna be the only thing I do during this project time, so I rather just do it, start now, and then try to fix things as they go along. I apologize if I'm not making as much sense. I have been waking up consistently around 6 a.m. I go to bed at a reasonable time, about 10 or so, but my brain usually doesn't get active until 12. Um, so I apologize if I stutter or words don't flow as they should. Oops. You see my Discord. That's fine, whatever. Anyway, so yeah, let's get started. So first thing we need to do is figure out a tech stack. Well, actually, the first thing we need to do, we'll figure out the tech stack. I'm also trying to think about making this a repository template, because like I said, this is taking inspiration from my Stardew Bot repository, so I feel like if most of my projects are going to follow a template like this, I might as well make an actual template. So I'm actually going to probably do that now. Alright, let's look this up. Right. How to GitHub, how to make a repository template. Alright, so you want to go to settings, template repository. Okay, so we're just going to call it template repository. Template, template for great description. We'll include README, project plan, repository, PR templates for templates for bugs and features. Is there anything else I want to add specifically in this repository? README, I don't really think I need a roadmap. I can't really put in linting because it's not always going to be the same language. Yeah, it's fine. Yes, please add a README. Do not add a license. Alright, so we got that done. I will set that up later, but I already made the repository for this, so I will set that up and probably just move the files over into the repository template. Productivity app, okay. So, what I want to decide the language, so I do want to have a database. I definitely think it's very worthwhile to have a database and then some sort of type language in order for this to just better work. Because if I do something like JavaScript, it's just going to get too messy. So I need to use language like TypeScript, and I don't want to use Python. Number one, because I actually haven't used Python that often. My first language was Java, so going from Java to Python, it's very funky. I can do it. I think for a project like this, it's very useful to have types. Plus, I think the scope of this is a little bit too large for me to just jump into a relatively new language. I'm still trying, well, not new, but like language I'm still trying to understand. So I think it's best if I just like don't do it in Python. So right now my brain is thinking of TypeScript, which is fine. I don't really care. Yeah, I think I should use TypeScript. Speaking of which, I'm going to open that dev diary. I'm going to create that dev diary document so I can be writing this stuff down. All right, so we're going to put in dev diary. And then we're going to put the heading of 6. It's a 7. It's July. So 7/6/25. All right. So the first thing I'm doing is just think about tech stack. I do not want TypeScript. I don't want Python. Python, relatively unfamiliar language, lacks types. All right, I don't want JavaScript because similar to Python, lacks types. Um, all right, actually, let's just do about pros and cons lists. So we're going to talk about language. So we're going to say Python pros, and then we're going to make it a cons. Then JavaScript. So we have JavaScript. We have C#, Java, TypeScript, which I'm going to move right above JavaScript. I don't really think there's any other than I could theoretically do C++, but similar to JavaScript, or excuse me, Python, I'm not familiar with it. And if I'm going to be using C++, I feel like I can also just use C#. So I think those are my options at the moment. So we're going to put a pros list, cons. So pros for pros, I don't know. I don't know. Sorry. I don't know. It's relatively easy language, I guess. Easy language to learn, I guess. All right, let's me ask ChatGPT what it thinks. So between these languages, I said I don't want to give it Python or JavaScript. So I guess I will still write it out why I don't want these easy to learn. Lacks types. All right, and then JavaScript. Yeah, I don't know why we familiar. Good for both web and mobile development. TypeScript, similar to JavaScript, good with familiar, contains types. Any cons with TypeScript? I don't know. All right, let's see. It's gonna be a long ass document, I can tell. So not good for CLI. CLI. Front end development. I can make it work. It's gonna take some time, but I can make it work. All right. Easy to evolve. Okay, so where it's saying the pros with TypeScript are great for cross-platform UIs with React and React Native. Can share logic across web, CLI, and mobile. Huge ecosystem for task scheduling, UI auth, and etc. Easy to evolve a browser app based then packages as desktop via Electron or mobile via Expo. Best use case scenario if you want to prioritize web first and mobile first with the fastest. I'm just going to copy that. C#, CLI, great for CLI and desktop GUI, native performance, type safety. All right, great for CLI, native performance. Type safety and modern syntax. Most comfortable language. Cons. Slightly heavier setup. I'm not planning on ever using Linux, but that is always a possibility, so okay. And MAUI is still evolving, better for desktop Androids at the moment. Best case scenario, start with CLI first and grow into native GUIs. That is true, but I don't really I want it to be just set up at the front. I don't want to think about refactoring into another thing later, so we'll see. Java was FX and Android CLI. Old, good, and Silverbright was solid CLI and and Android support. That's good. Great libraries for scheduling and persistence. I bet. Excellent performance. More verbose than C# and TypeScript. Yeah, it's Saba. So Kant's more verbose. GUI development is not as modern as web tech, yeah, and it's not really that useful. Best case scenario, if you're prioritizing Android plus CI without needing browser support, I don't think I will. So if I want this best on mobile, I think TypeScript will be best. Yeah, I'm going to use TypeScript. Alright, so we have one thing, well, technically, one half of a thing on our roadmap checked off. So now we need to think about the database. And I really think it's important to separate this into a database. So just not all think about each other. Think about database. Actually, let me just do this. Think about. Oh, I'm stupid. I already did that. Language, and then we can go down here and then go to database. So, what are my options for databases? All right. So now I'm asking ChatGPT for databases. The only one I'm really familiar with is Postgres and SQLize. Um, so just a reminder, I do generally have a schema, but I have it not planned out. I want this to be cross-platform. I want tasks to have subtasks up to 20. I need reminders, reoccurring rules, plans, and then analytics such as habits, streaks, and then at some point I will need to sync on both desktop and mobile, and usable offline. So let's talk about some pros and cons. So it gives you some options. We have SQL Lite with Prisma, Drizzle, or SQLize. Pros are, actually, let me just do this. And then shit. All right. Pros with SQI, no server needed because it is local. ACID compliant SQL agent. What does it mean to be ACID compliant? ACID compliance enables transactions are processed excuse me. Are processed reliably. What does that mean? Automaticity, consistencies, isolation, durability. All right, fine, that's good. I'll write a note here. Sorry, I'm just looking at some documentation.
Go ahead. Can you compose it? Like 5 minutes, because I gotta get ready.
Alright, what does that me mean? I'm gonna put this over here. We can learn together. All queries and transactions must succeed the transaction. If one query fails, the entire transaction fails. Imagine if your self-service machine is fast food. The transaction in this case is ordering food consists of two separate operations: select food and make payment. Both of these transactions must succeed for the transaction to succeed. If either fails, the transaction fails. You select burger, fries, machine prompts you to pay, and only after you pay is processed successfully sent order to kitchen. Moments later, your entire order is ready and you pick it up at a counter. This is an atomic operation. Transaction ordering food is either entirely completed if you select your food item and make a payment not completed at all, or not completed at all. Either part of the transaction failing means the entire transaction will fail. If your payment fails, the machine won't process any part of the order, so the transaction fails. If you make a payment without selecting a food, the transaction also fails, as there is nothing for the kitchen to prepare. Now, consider an alternative transaction: sit-down restaurant where you order several dishes. As each dish is prepared, it's brought to your table. Again, transaction ordering food, two separate. Select food, make payment. And non-atomic failure does not stop the transaction from completing. Since you pay after you finish your meal, partial failures do not cause the transaction to fail. Dine and dash, order. Okay. If several SQL queries are grouped together in a transaction, atomicity is a guarantee that should any query fail for any reason, then the transaction is aborted and the database returns to its previous state as if nothing happened. Without atomicity, if a failure occurs while some queries are running, it is difficult to know which queries have been committed, that is, completed, and which have not. Running the queries again after failure can compound the problem, since you risk introducing incorrect data to the database by rerunning queries that had previously succeeded. Okay. Atomic transactions prevent such uncertainty since you have the previous transaction failed. It failed in its entirety, and you can simply retry without worrying about introducing inconsistent data. What does consistency mean? Consistency can mean different things in cloud/software engineering, depending on the context. In this case, C is most likely added to make the acronym work. Consistency in the context of ACID means consistency in data, which is defined by the creator of the database. The technical term for consistency in data is called referential integrity. Referential integrity is a method of ensuring that relationship between tables remain consistent. It's usually enforced through the use of foreign keys. To understand referential integrity, consider the following list: books, All right, is it just going to talk about rule? Okay, I know what. That's a book card. The rule in a library is that a book can only be listed as a borrower's card if it exists in the book card. This is referential integrity. If someone tries to list a book on a borrower's card that is not on the book card, that is, the book card doesn't exist. If the book doesn't exist in the library, the system will not allow it. Okay. We'll link this over here. No, I actually wanted to. No, that's not what I wanted to do. Whatever. Actually, let me just get rid of the heading, and that will work fine. Edit. There we go. Fuck. Okay. So where am I? All right. Well, atomicity, isolation, and durability are properties intrinsic to the database itself. Consistency in the data or referential integrity is not a property intrinsic to the database. Consistency is defined by the creator of the database. The application calling the database relies on the atomicity and isolation properties of the database to maintain consistency. Okay. So it's pretty much just making sure that your relationships are working. Your schema is not going to screw up anything in the future. What does isolation mean? Isolation is a guarantee that concurrency running transactions should not interfere with each other. Concurrency here means two or more transactions trying to modify or read the same database records at the same time. There are three levels of transaction isolations. I'll just explain the first two main ones below, arranged in order from least strict to most strict. All right, committed. This gives two guarantees. It prevents dirty reads. Okay, I gotta be right back.
Garage.
All right, sorry, I'm back. Okay. All right. So, dirty reads and dirty writes. Reading data from another transaction that has not been committed is called a dirty read. With the recommitted isolation level, you only see data that has been committed by another transaction. No dirty writes. Overwriting data that has already been written by another transaction but not yet committed is called a dirty write. To understand how recommitted isolation works, consider the following example. Imagine a fast food restaurant where only one last special burger is available and two hungry customers, Marie and Marco, are trying to buy it simultaneously. Two customers are ordering the burger at the same time. Marie checks the availability of the burgers and see the last one available. Unknown to her, Marco's order is being processed but has not been finalized in the system, and he has not paid. Since his order has not been finalized, Marie is not aware his order conflicts with her own. This is similar to transaction reading the most recently committed data, where it does not see uncommitted changes like Marco's pending order. Marie places an order based on this incomplete information, thinking the burger is available. When Marco pays, the system updates to show that there is no burger left. This is similar to a transaction being committed. Marie's order will have been aborted since there are no burgers left. The key point here is step 3. What if Marco pays and the payments fail at this stage? Then the transaction will not be committed and there will still be a burger available for Marie. In this example, recommitment isolation ensures Marie is not prematurely excluded from buying the burger just because someone said they wanted it. Only committed transactions can be read. Therefore, the burger is available to be ordered as long as no one has paid for it. Okay. That makes sense. Repeatable reads. The repeatable read is a more strict isolation level in that it has the same guarantee as recommitment isolation, plus it guarantees the reads are repeatable. A repeatable read guarantees that if a transaction reads a row of data, any subsequent reads of the same row within the same transaction will yield the same result, regardless of changes made by the other transactions. This consistency is maintained through a duration of the transaction. When a transaction reads the same data twice, but it sees a different value in each read because the committed transaction was updated between the two reads, this is called a fuzzy read. The repeatable read isolation level presents fuzzy reads. Fuzzy reads are neither inherently good nor bad. It all depends on what you're trying to achieve. Fuzzy reads are bad for long-running read-only transactions since new writes are likely to occur during the transaction. In this case, cause inconsistency in the data. Examples of long-running read-only transactions are database backups and analytical queries typically used in data warehouse. Okay. Repeatable reads are usually implemented by the DBMS by reading from a snapshot of the database, which remains unchanged for the duration of the transaction, thereby ignoring any new committed writes in that period. So, I'm not gonna lie, this makes sense to me. This does not make sense to me. Let me read it again. Repeatable read is more of a strict isolation level in which it has the same guarantees as a recommitted isolation, but it guarantees the reads are repeatable. A repeatable read guarantees that if a transaction reads a row of data, any subsequent reads of the same row of data within the same transaction will yield the same regardless of changes made by other transactions. Okay. This consistency is made throughout the entire duration of the transaction. When a transaction reads the same data twice, but it sees a different value in each read because a committed transaction has updated the value between two reads, this is called a fuzzy read. The repeatable isolation prevents fuzzy reads, okay? Fuzzy reads are bad in the long-running read-only transactions since new writes are likely to occur during the transaction, and this can cause inconsistencies in the data. Examples of long-running read-only transactions are database backups and analytical queries typically used in a data warehouse. Repeatable reads are usually implemented by the DBMS by reading from a snapshot of the database, which it remains unchanged for the duration of the transaction, thereby ignoring any new committed writes at that period. Okay, that makes sense. All right. Durability is a guarantee that a change made by a committed transaction must not be lost. All committed transactions must be persisted on durable, non-volatile storage that is on disk. This ensures that any committed transactions are protected even if the database crashes. Naturally, durability cannot be protected against destruction of the disk which stores the data. Additionally, redundancy can be added by having backups of your database stored separately from the original. All right, bringing it together, ACID provides a set of guarantees when working on it with a DBMS. While most relational DBMS are ACID compliant, the implementation of this compliance can vary. Atomacy ensures that all parts of the transaction are completed and none at all. Partial failures are not allowed. Consistency or referential integrity ensures the data it remains accurate and reliable, adhering to predefined rules. Unlike other priorities, consistency is not intrinsic to the DBMS itself. Instead, the application calling the DBMS or the database relies on the atomicity and isolation properties of the database to maintain consistency. Isolation is a guarantee that concurrently running transactions should not interfere with each other. This is arguably the most important property because a DBMS can often have different default isolation levels, which may need to be changed based on what is needed in your application. Finally, durability is guaranteed that changes made by a committed transaction must not be lost. Okay, great. I'm happy I went down that rabbit hole. That was not sarcasm. I'm very happy I learned something. I can look at it later. So, as we know, SQL. Oh, I didn't write it here. Portable tiny machine can scale. Oh shit. Can scale to web with Postgres later. Okay, that's fine. Cons: no built-in sync. We need a custom sync for mobile layers. I don't like that. That makes me a little upset. Slightly slower at scale with many write-heavy tasks. Okay, it's pretty bad. Doesn't enforce advanced data types like progress. Okay. Best for local first CLI apps, then that may migrate to Postgres. Okay, but that's not really that good for me because I do want to sync. That's like a really important factor to me, so that's concerning. So I don't think SQLite will be good in my scenario, which some people may see as good or bad, or at least it's good and bad in its own cases because I am most familiar with SQL. Well, not most familiar, but I am pretty familiar with SQLite. So, I guess I'll be learning something else, which is good, but it may take a learning curve. But hey, everything has a learning curve, so whatever. Why do these have headings? Hello? So, Postgres with SQLite or Prisma, you already know it. So, versatile, rock solid. powerful relation database, which is good. Great for deploying relationships like tasks and plans. That's good. That's why I really want to use it. Broad ecosystem. Okay. Advanced features, JSON, MB, or full text search. I'm not familiar with that is. So I'm just going to leave a note here. Not familiar with this. Okay, cons. Needs a local server running, harder to bundle in CLI app. I'm most likely going to host this. I already have hosting thing for my other bots, so I'm not really that sure. Heavy setup for non-server apps. Whatever. Overkill for local only CLI. Not doing that. So not really something I need to worry about.